So what we're going to do is we're going to talk about a thing called radicals with trig. So we're going to use that to actually solve a lot of problems today. But preliminaries, we need to go and identify some new concepts. So in addition to all these identities that we were looking at before, the reciprocal identities, the quotient identities that we had here, the Pythagoras identities that we were looking at, we're also going to look at this special one right here. I want you to add this to your formulas page. So we have sine x, sine of 2x is equal to 2 of sine x cos x. And I need you to memorize that cosine of x, cosine of 2x, could be either written as this or this. And we're going to use that to our advantage because these things are difference of squares, essentially, that you learned in grade 11. Now, these things aren't the nicest equations to work with, but all of these have some form of difference of square that we can use. So this one here also has a difference of squares on the bottom, and we can use that to our advantage at some point in today's lesson. Make sure you copy that down, and we'll move on to the lesson. So what I want you to do right now is I want you to rewrite these without radicals. Okay, so now the only hitch is you start with something that you recognize, but then what we're going to do is we're going to substitute certain values in, okay? So here is our solution for this problem. We first have to substitute. So we have this. Now we'll expand. So we end up with 16 sine squared theta because 25 on the bottom denominator of our expansion of 4/5 sine squared becomes 16 over 25, and we simplify, and we end up with this. Now what we can do is we can factor. And now, since we have 16 times 1 minus sine squared theta, you need to recall this. And now we finish. We end up with the square root of 16 cos squared theta. And unlike the math that we studied before, where we would always take the plus or minus, we don't have that option here. In these problems, what we're going to do is actually use the principal root. In this case, the square root, we're using the principal root, which is always going to be positive. So when we take the square root of 16 and the square root of cos squared theta, what happens is you end up with 4 times the absolute value of cosine of theta. Okay, and that's it. We're done. Now, you get the 4 cos theta absolute value, but we don't care. All we just want is 4 cosine of theta. So you can skip from here straight to there and skip that middle. For question number 2, we're going to do the same thing again. So now we have this problem, and what we're going to do is we're going to substitute directly in, and you'll notice that our quadrant goes from 0 to pi over 2 for theta. So let's go and substitute. So subbing, you get this. Expanding the squareds, you're going to get this. And so now we're going to factor the top. And now that we factored the top and we have common factors on the top and bottom, we'll cancel them out. And now once we've got that, let's simplify underneath the square root sign here, which gives us the square root of sec squared theta over minus 1 over sec squared theta. So now I could write this as the square root of 1 minus 1 over sec squared theta, right? And I want you to recall, so you're going to recall that sec squared theta is equal to 1 over cos squared theta, but then what happens is you end up with cos squared theta could also be written as 1 over sec squared theta. And we'll use that to substitute for 1 over sec squared. Now, so now you get 1 minus cos squared theta, but you need to recall this. Remember from our identities. This is a Pythagorean identity. So sine squared theta is equal to 1 minus cos squared theta. And we just substitute that in. And we end up with the following. We end up with the square root of sine squared theta. And we're going to take which gives us the absolute value of sine theta, which is really just sine of theta. So before we started with our double angle formulas, you're going to use them in this next question. So imagine you're going to use the double angle formula to simplify this first equation. So I want you to remember what the double angle formula states. So cos squared x is equal to cos squared of 2x is equal to cos squared x minus sine squared x. So this part and this part is essentially doubled at the front of cosine. So here's what we end up having. So the left side of the equation is that. So we're going back to the original. So we end up with cosine of 2t plus 2t, which gives us the cosine of 4t. And we're done. So now we have something that looks like sine. So you got 4 sine of x over 3 plus times cosine of 4 of x over 3. So here's what we can do. This is what you need to recall. You have to recall that sine of 2x is equal to 2 sine x plus 2 cos x. So what we can do is we can take that problem and make it look like 2 of something. So let's do that. So we got 2 of 2 sine of x over 3 cosine of x over 3 in brackets. So now we have something here that looks like what we're looking for, okay? So now what we're going to do is we're going to move all this stuff up and we're going to continue with our problem. So now you've got our 2 of something in our bracket. So now what we can do is we can replace what we have there in our bracket with sine of 2 times the stuff that was inside here. So it's this and this. So we write x over 3 in our bracket, which gives us 2 times sine of 2x over 3. And we're done. So for your final example, I want you to actually write down the example that I have put on a line for you. Okay. And then I want you to do homework. And that homework is going to be page 232, number 1 to 7, and you're going to do the odd ones. You're going to do question number 32, 31, and 32. You're going to do 35, and you're going to do question number 39. That is your homework for this last lesson.